Good day, everyone. I am Cheryl May E. Coronado, and today I will be discussing topics under tracking work. So these topics are control schedules for time and cost, relationship between time and cost, and integrated cost or schedule work. So what is CBS? So first, let's define these acronyms so that later we'll be able to understand what I'm discussing. So CBS or cost breakdown structure is a breakdown or hierarchical representation of the various costs in a project. The cost breakdown structure represents the cost of the components in the work breakdown structure or WBS. So the CBS is a critical tool in managing and the financial aspects of project and creates a structure for applying measurable cost control. The CBS is required for project business to appropriately manage the financial aspect of any project. It is the planning structure financial controllers use to create budget and calculate various financial metrics such as estimate at completion, cost to complete, variances, and earning value. So what is WBS? So a work breakdown structure or WBS is a visual hierarchical and deliverable-oriented deconstruction of a project. It is a helpful diagram for project managers because it allows them to break down their project scope and visualize all the tasks required to complete their project. So it is the tool that utilizes this technique and it is one of the most important project management documents. It is single-handedly integrates scope, cost, and schedule baselines ensuring that project plans are in alignment. So what will be the relationship between CBS and WBS? So a cost breakdown structure is a terminology within project management. It is closely linked to what is called a work breakdown structure or WBS, while the WBS represents all the tasks that need to be done within a project. The CBS represents all the costs that will incur in the project. Good cost breakdown structure provides insight on overspend of underspend against your plan. Having a good structure makes it easy to understand deviations. When you see deviation from your plan within a cost category early, it is easier to make the right decisions for improvement. Someone might have made a mistake. There can be cases where certain cost elements were out of original scope. If this occurs, the cost might be subject for a charge to the client. Furthermore, you will be easily identify areas you can reduce spend to ensure you stay on plan. So the CBS and WPS helps in order to organize your plan. So it is also important in project management so that maiwasan yung mga mistakes and it help na ma-align yung mga kung ano yung mga gagawin sa projects. So, control schedules for time and cost. The CPM network diagram shows the sequencing of activities that represent the work packages identified by the WBS. The expected time and cost that is required to perform each activity can be obtained from the work packages of the WBS in order to establish the parameters of control of cost and time. For each activity of the EPC project shown in Figure 92 and Table 92, provides the cost and duration along with the team member who is responsible for the activity. These costs and durations are directly related to the WBS and their expenditure is directly related to the work that is produced. To measure the progress of the project, the actual costs and durations are compared to these control costs and durations. So the total cost of the project includes the direct costs from the previous paragraph plus indirect costs, contingency reserve, the profit. A CBS for the project includes all these costs. However, only the direct costs that are tied to the WBS are used for project control purposes to manage the accomplishment of the work. Indirect costs include support personnel, equipment, and suppliers that are not directly traceable to the project. The cost of insurance, bond, general office, overhead, etc. are also excluded from the project control system for monitoring costs and managing work because these items are fixed at the beginning of the project and they are independent of the work accomplished. The management of these costs is generally a function of the accounting department because the project manager and his or her team usually do not have control of these costs. These costs are typically distributed over a specified period of time and will expand or contract with the schedule. So a good description of the relationship between engineering CBS and WBS is provided in C2 publication 6.1 Project Control for Engineering. Figure 93 is an example of the publication that illustrates a total engineering budget matrix. CBS includes all elements in a budget matrix that have been given a dollar amount. The total dollar value of all the elements is the total engineering budget. The WBS for the project consists of budget items from CBS for tasks that produce deliverables, design calculations, drawings, and specifications. So the figure 93, the functions that are chosen for work control are shaded in a matrix and design and drawing specifications, procurement support, and field support. The detailed WBS would be expanded from their budget items into areas, systems, and subsystems that are defined the total project. For example, the deliverable to be produced by the electrical would be a drawing list that included all drawings for electrical work. The number of work hours for each drawings and the number of work hours of calculations that are required to produce the drawings would represent the budget. So the schedule for the work is the total time to produce the final drawings, including the overlap of design, calculations, and design drafting. Discussed in Chapter 8, most engineers prefer a bar chart for scheduling individual design tasks. However, for project control, the individual bar chart must be developed into activities on the CPM diagram for the total project schedule. The start and finish of each activity of the CPM engineering design schedule is a composite of all tasks of the work package. So, as you can see on the figure, we have task of work package and we have duration. Under task of work package, we have project engineering, electrical engineering, CAD operator, total budget days, and the duration naman, we have 7 days, 19 days, 8 days, and 34 days. So, may schedule yung project engineering, electrical engineering, and CAD operator. So, which is yung project engineering have 7 days, electrical engineering 19 days, CAD operator 18 days, and total budget of 34 days. So, in this figure 94 is an example from the publication that shows the WBS is the direct cost portion of the CBS. The WBS includes work that is budgeted, scheduled, and controlled. The estimate should be prepared in the same organizational format as the WBS. The quantity takeoff from the plans and specifications is used as the basis for direct labor, materials, and equipment for costs. The cost estimate should also consider the method of construction and the sequencing of work for development of the project schedule. So meron tayong example ng WBS dito and CBS. So dito sa WBS, we have a construction of a house. So as you can see, we have a in level 1, so naka-align sa level 1, we have internal, foundation, and external. So sa internal, under internal, we have electrical and plumbing. So under foundation, we have excavate and steel erection. And sa external naman, we have masonry work and building finishes. So, in the other hand, we have also here the phase-based work breakdown structure. So, we have design, procurement, construction, inspections, turnover. So, as you can see, align yung naka-organize yung plans. So, dito naman sa CBS, so as you can see, from the word itself, so cost. So, ito yung mga budgeting, mga budgeting sa in terms of materials, sa sweldo ng mga workers, ng mga iba pang cost. So, as I said earlier, so yung WPS breakdown project scope and visualize all the tasks required para makumpleto ang isang project. So, WBS naman manage the various tasks in your project, and also it controls cost in the project, and it creates budgets and calculate various financial metrics. So the general superintendent who will be responsible for the project on the construction and jobs site must be involved in developing the detailed construction schedule during the early stages of the project development. It is often necessary to develop a construction schedule before the construction contractor has been identified. Construction contractor usually performs some work with direct hire, force account personnel, and contracts portions of the work to one or more subcontractors. Since many subcontractors do not have an elaborate project control system, the alignment of the work to a subcontractor should be a work package that has a scope of work, budget, and schedule that is defined in sufficient detail so the subcontractor responsibilities and duties are clearly understood. The subcontract work package must be compatible with the WBS, otherwise there is no basis for control. So, however, each subcontractors must be included in the total project schedule, since the work of any one contractor usually affects the work of other contractors on the job, which can impact the completion date of the project. The unsuccessful procurement of material is a common source of delays during construction. A procurement plan must be included in the project schedule to guide the purchase of contractor-furnished materials. Although the contractor generally obtains most of the material as a part of his or her construction contract, many projects require the procurement of special materials and equipment that is unique to the project. Also, the owner may procure equipment or bulk materials that will be installed by construction contractor. Project schedule should identify and sequence all the activities that can impact the delivery of special equipment and material. So, yung previous sections presented kanina are the list of activities, costs, durations, and coding system for the EPC project shown in figure 9-2. So, the preparation of this data provides the base of the project monitoring and control system. For example, to evaluate the engineering design phase of the project. So an S-curve can be produced that shows the distribution of costs of all design work. So this curve is obtained using the coding system of table 9-1 by selecting all the activities in which the first digit of their code is greater than 0 and less than 3. So additional reports can be computer generated as discussed in Chapter 8. For example, this figure 96 shows the graph of daily costs of all in-house engineering design. It can be obtained by selecting all activities that have a I in the first digit of their code number. A similar curve can be obtained for work hours, which would show the personnel requirements needed to perform the work. So, itong table 93 naman is a partial listing of the project control schedule for all activities in the project. Only the first and last portion of the total schedule is shown to illustrate the type of information that can be obtained of all the 60 activities in the total project. Critical activities are those activities that have zero float time and are denoted by the letter C. At the left of the activity number, major milestones events are also noted on the schedule. This schedule is a summary level scheduled report that integrates engineering, procurement, and construction. So itong table 94 naman dito sa kabilang side is a monthly cost schedule for the entire project. The distribution of costs are shown in the early start, late start, and target basis. The percentage time and percentage cost distribution are shown in two rightmost columns. There is a nonlinear distribution between cost and time. For example, at the end of the 6 months, which represents 33% of the time of completion, only 17.9% of the costs are anticipated to the extended. For example, at the end of the 6 months, which represents 33% of the time of the completion, only 17.9% of the costs are anticipated to be expended. However, at the end of the 11th month, 64.1% of the time, 54.3% of the costs are expected to be expended. So, in topic 2, we have relationships between time and work. Measurement of design work is difficult because design is a creative process that involves ideas, calculations, evaluations of alternatives, and other tasks that are not physically measurable quantities. Considerable time and cost can be expended in performing these tasks because the results such as drawings, specifications, reports, and etc., which are measurable quantities of work, are ever seen. The measurement of design is further complicated because of the diversity of work. For example, all of the design calculations may be complete, half of the drawings may be produced, and yet only one-fourth of the specifications may be written. For this situation, it is difficult to determine how much work has been accomplished because this work that is produced does not have a common unit of measure. The criteria for determining the percent complete for measuring work must be developed and confirmed in writing with the project team members prior to commencing design. This provides a common basis for the monthly evaluation of progress. A weighting multiplier can be assigned to design tasks to define magnitude of effort that is required to achieve each task. The sum of the weighting factors is 1, which represents 100% of the total design effort. Determination of each weight should be a joint effort between the project manager and the designer who is responsible for performing the work. A significant amount of overlap work is necessary during the design process. For example, initial drafting normally starts before the design calculations are finished. Likewise, final calculations are often not complete before the final production drawings are started. The project manager and his or her team members conjointly define the overlap of related work to show the timing of tasks throughout the duration of the project. So the table 9 to 5 is an illustrative example that lists work items, weight multiplier, and estimated timing for each task required in a design effort. Further division of weight multipliers within each category may also be necessary. The information in Table 9 to 5 is provided for illustrative purposes only. Because each project is unique, it is necessary to define the weight multipliers that are appropriate for each individual project. The timing of design work depends upon the availability of personnel. This information can be compiled from a summary of the individual design work package. To manage the overall design effort, a work or time curve can be developed from the information in Table 9 to 5. So, in Figure 9 to 7 naman, the upper portion of Figure 9 to 7 is a series of graphs that represents each design task individually arranged in order of occurrence. So the slope of each graph is the ratio of the weight multiplier to the time required for the work to be performed. The lower portion of Figure 9 to 7 is the work or time curve for the entire design effort, and it is obtained by a composite superposition of individual graphs. The curve represents the planned accomplishment of work and serve as a basis of the control of comparison of actual costs accomplished. It is be superimposed onto the time or cost as curve that was discussed in the preceding section. This forms the overall integrated cost, schedule, or work curve that is discussed later is subsequent section of this chapter. Construction involves many types of different work that have different units of measurable, such as cubic yards, square feet, pounds, or each. Thus, it is convenient to use percentage as a unit of measure of equipment, and control of overall construction. The procedure used for measurement of design can also be applied to construction. For example, a project may consist of three major facilities: site work, a concrete office building, and a pre-engineered metal building. A weight multiplier can be applied to each of the three major facilities, along with their planned sequence of occurrence, reference table 96. So the procedure is a top-level summary of all facilities in the total project. This same procedure can be used for each facility or parts of a facility, depending upon the complexity of the project and the level of control that is desired by the project manager. So, Table 9 to 6 only lists three major parts of the projects, which are the facility, weight multiplier, and project timing. So, in the facility, we have site work, concrete building, and metal building. In sa site work naman, ang multiplier is 0.2 and ang project timing is 0 to 35%. In concrete building, we have 0.40 in weight multiplier. In a project timing, we have 15% to 75%. Sa metal building naman, ang weight multiplier is 0.35 and ang project timing is 65% to 100%. The total number of weight multiplier is 1. In figure 9 to 8 naman, which is in the other side, shown the composite of the planned accomplishment of work. The upper portion of figure 9 to 8 is a graphical display of the overlap and sequence of each of the three major facilities. The lower portion is the integrated work time curve for the entire project. It is obtained via composite superposition of the three individual graphs of each major facility. The procedure is a top-level summary of all facilities in the total project. This same procedure can be used for each facility or parts of facility, depending upon the complexity of the project and the level of control that is desired by a project manager. At the lowest level, it may be possible to use a unit of measure of work that can be physically measured at the job site rather than using a percentage. For example, wire pulling can be easily measured in linear feet or contour piers, can be measured in cubic yards. However, some precautions must be used when physical quantities are used to represent work in place of a percentage. To illustrate, the construction of concrete piers involves drilling, setting steel, and placement of concrete. For a project that has 18 piers, project report may show all piers drilled, steel set in 9 piers, and concrete placed in 3 piers. If cubic yards is only measure of control, only 3 of the 18 piers should be reported as complete, which would not include the drilling and steel work that is accomplished. For this situation, a weight multiplier system must be developed to account for each task that is required to construct the piers. As previously discussed, the sum of all weights must equal 1 to represent 100% of the work. In topic 3, we have integrated cost, schedule, or work. So, experienced project managers are familiar with the problems of using only partial information, such as only cost or time to track the status of a project. To illustrate, half of a project budget may be expended by the midpoint of schedule duration, but only 20% of the work may be accomplished. A monitoring of only time cost would indicate the project is going well. However, upon the completion of the project, there would likely be a cost overrun and a delay in schedule because the measurement of work was not included in the project control system. Thus, a project manager must develop an integrated cost schedule work system which provides meaningful feedback during the project rather than afterwards. The status of a project can then be determined and corrective actions taken with the corrections can be made at the least cost. The preceding section presented the relationship of cost, time, and work time for project control. However, evaluating this relationship separately does not provide an accurate status of a project. A cost schedule work graph can be prepared that shows the integrated relationship of the three basic components of a project: scope, work budget, cost, and schedule of time. Figure 99 is a graph that links cost on the left-hand ordinate, time on the abscissa, and work on the right-hand ordinate. The upper curve is simply the cost and time S-curve that has been discussed in the previous section of this book. The lower work time curve shows the relationship between work and time throughout the duration of the project. Thus, the graph is simply a composite overlay of the information previously presented. The unit of cost is dollars and the unit of schedule is days, which are easily determined units of measure for any type of the project. The unit of measure of work is presented as the percentage, which provides a common base of all parts of the projects. As previously discussed, a project may have three types of buildings. So these are concrete, steel, and wood frame. So an appropriate unit of measure for work would be cubic yards for the concrete building, pounds of steel for a steel building, and board feet of lumber for the wood frame building. However, since it is not possible to add cubic yards to pounds or board feet, percent is a dimensionless unit of measure that conveniently be used to represent work. Although percentage provides a common unit of measure of work, a multiplier is necessary to define the distribution of work for each part of the project. For example, the project structure 35% for the steel structure and 20% for the wood structure, which when combined represents 100% for the total project. Factors that may be considered for determining the multiplier includes the work hours, cost, and or the time to complete the work. The multiplier that is selected involves both of quantitative and qualitative evaluation of the project based upon good judgment and should be determined as a joint effort by the key participants of the project team. So that's all. Thank you.